Hi, welcome to Darth Dragon Does Math. Right now we're doing zero and negative exponents. What this means, well, we'll get into it. I'm going to do a couple examples first before I get into those because that's not the only type of exponent rules and interesting examples we can use. So for this first example, if I have 5 times 6, 5 to the fourth power times 6 to the fourth power, and I want to simplify that down to exponential notation with one base, one exponent. You might notice that the bases are different, but the exponents are the same, and that's nice. So what that means is that can actually become 5 times 6 to the fourth power. Instead of simplifying the exponents, we're just simplifying the bases. And I don't know if there's a fancy term for that, but I wanted you to at least see it, where this becomes 5 times 6, which is 30 to the fourth power. This next one, again, we have 5, so this is 2x to the fifth power times 3y to the fifth power. Since we have the same power, we can make this 2x times 3y all to the fifth power. And then from here, all I'm going to do is just multiply the numbers. Those can simplify. 2 times 3 is 6. So this becomes 6xy to the fifth power, and that's as simple as that one can get. This next one, simplify the following expressions into exponential notation. So this is 5 to the fourth power squared times 6 to the eighth power over 10 to the eighth power. Again, this is nothing new. I'm just kind of reminding you. So using the the power rule, power of power, this becomes 5 to the 4 times 2 is 8, 5 to the eighth power times 6 to the eighth power all over 10 to the eighth power, and then hopefully we notice that there's just a bunch of eights, eighth power, eighth power, eighth power. So this becomes 5 times 6, which is 30, to the eighth power, divided by 10 to the eighth power. And even then, I can simplify 30 divided by 10 as 3. All of this is equal to 3 to the eighth power, and you can see how that is significantly reduced. So here we're going to come to our new information. 0 power, 8 to the 0 power, and then here this is going to be to the negative fourth power. So before I do that, I want to show you something. So we all know, let's take a number. The easiest one to do is 2. Okay, so 2 to the first power is equal to 2. That's relatively understandable. 2 squared, that's equal to 2 times 2, that's 4. 2 cubed, that's equal to 2 times 2 times 2, that's 8. And if you notice, if we're going up, we're multiplying by 2 each time, and that's pretty simple for us to comprehend. But I want to think about what would happen if we started going backwards. So let's go backwards. And 2 to the 0 power, so this is going 3, 2, 1, 0. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is actually 1, and we know that. We know it. If we follow that pattern, and it does follow the pattern, but what happens is if I ever write out 2 to the 0 power, most of our instincts say that that is equal to 0, and it's not. It's equal to 1. I'll show you another proof here in a moment. And if you keep following this, 2 to the negative 1, that's equal to 1/2. We are dividing by 2. 1 divided by 2. The next one, 2 to the negative 2, is equal to 1/4. And essentially what this grants us is that if I have a negative power, it's equal to basically 1. So we know two things. X to the 0 power, using this right here, is equal to it's just equal to 1. The number 1, no matter what. Doesn't matter. It could be 1,000 things. But if we put those 1,000 different things to the 0 power, it's always just equal to 1. And then x to the negative 2, or negative power, we'll say negative a, is equal to 1 over x to the a. And those are the two rules. Think about it. 2 to the negative 1. Well, this is equal to 1 over 2 to the first power. 2 to the negative 2. Well, 2 to the positive 2 is 4. 2 to the negative 2 is 1 over 4. So negative powers are just whatever that is flipped. Going back to this, I feel like this is the thing that gets a lot of people. I want you to think about it one more way. So imagine what 2 to the first power is times 2 to the negative 1, right? And I'm coming off the top of my head, sorry. Product rule says that this is 2 to the 1 minus 1, right? Which is equal to 2 to the 0 power. Okay. Now, 2 to the first power times 2 to the negative 1 power is also just 2 times 1/2, right? 2 to the first power we said was 2. 2 to the negative 1 was 1/2. So 2 times 1/2. Well, 2 times 1/2 is 2 over 2, which is 1. So again, 2 to the 0 power is equal to 1. So just let that sink in. X to the 0 power is equal to 1. X to the negative power is equal to 1 over x to that power. So we got a few examples. So this is 8 cubed times 8 to the 0 power. Okay, so that's 8 cubed times basically 1. 8 to the 0 power is 1, which is 8 cubed. That's just equal to 8 cubed. This next one, 7 cubed times 7 to the negative 4th power. Again, excuse me, if we think about that, this is essentially 7 cubed over 7 to the 4th power. 7 to the negative 4 is equal to 1 over 7, 4. So all I'm doing is just taking the 7 to the 4th and I'm throwing it down across the division sign. And then from here I can simplify. 7 cubed, 7 fourth. Now there's actually more on bottom than there are on top, which is okay. Just all the ones on top will cancel out, and we always want to be left with 1. And then 4 minus 3 is 1. So we're left with 1/7. This one right here, I'm going to take all my numbers and first from the top, and then I'm going to, so 9 times 2, and then I have k negative 1 times k negative 3 over 27 k to the negative 6. 9 times 2 is 18. So my number is basically 18 over 27. My k's, this right here is k to the negative 4, negative 1 plus negative 3, and then k to the negative 6. And what's going to happen is these negative, anytime I have a negative exponent, it basically just switches sides. So this negative 4 is going to go down here and it's going to be positive, and this negative 6 is going to go to the top and it's going to be positive. And while I'm thinking about it, I'm going to make 18 over 27 2/3. Because 9 goes into both. 9 goes into 18 twice. 9 goes into 27 3 times. K to the 6 over k to the 4. And then 6 over 4, 6 minus 4, this becomes 2/3 k squared. Our last problem, we have 7 to the negative 2 times 7 to the 0 power, 8 cubed times 8 to the 5th power. So this becomes, excuse me, 7 to the negative 2 times 1, so this is basically going to cancel out, over 8 cubed times 8 to the negative 5th power. 8 cubed, so using the product rule, or yes, 3 minus 5, this becomes 7 to the negative 2 over 8 to the negative 2. 3 minus 5 is negative 2. So this becomes 7/8 negative 2. And the reason that I wrote it like this is to show you, see, we always want positive exponents. So to fix this, to make this negative, remember it becomes the reciprocal, whatever, well, 1 over x a. This actually becomes 8/7 squared. Another way to think about that is if I start here, I can bring the 5 to the top and the negative 2 to the bottom, and I'll hit 8 to the 5th over 8 cubed, and then 7 squared. 5 minus 3 becomes 8 squared over 7 squared, and then the 2 comes out, 8/7 squared. Again, same ending, maybe one's a little bit easier for you to wrap your head around. The back is all you. Turn that in to get credit for 8th grade math part 3 and hone your math skills. Look out. Math, 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 math.